All right, so today we're going to talk about a tool that really nobody's using out in the industry anymore. However, this is still a good tool. It's called a sled gauge, manufactured by Starrett. And I'll be honest with you, good luck finding one. You can find them used, and in good condition, they still command quite a bit of money. But I want to show you how to set this tool up correctly in the cylinder bore to get an accurate reading, because we want to use this tool to check for cylinder bore taper and out around. So we're not going to focus so much on the dial indicator on top of this tool, as this measures in thousandths of an inch, and the specifications for this engine are in 10,000ths of an inch. We're really going to use this tool to set up so we can measure from here to here with a micrometer and compare it to our specifications. So what we have here is a GM 2.5 liter or maybe even a 2 liter engine block, Ecotec engine block, and this block does have some issues, but we use this block here to train technicians on how to use measuring tools. So let's talk a little bit about this tool. You got several pieces to the tool here. So you have this knob here that actually would stop the movement of the measuring rod. And of course, there's all different length measuring rods that you can get for these tools, and they would typically be stored inside the handle of the tool here. And when you're using this tool, just be aware that there's one end of the measuring rod that's a convex. It's the end that has the machine groove on it. The other end's completely flat. So this goes to the inside of the tool. This is your measuring surface, the convex end of the tool. So you can see that moves freely in and out until I lock this down. Then it no longer moves, but the whole center of the tool does move. Of course, you can see the dial indicator moving right there. Now that movement's going to be stopped with this knob right here to stop the movement of that tool, or that piece of the tool. So I'm going to go ahead and loosen everything up, because we want to start with everything being loose, and that's including this handle. You can see this handle moves and flexes, and we can tighten this handle up and stop the movement of the handle. So everything needs to be loose before we start setting this tool up. Now, if you go into, let's say, General Motors service information years ago now for maybe a 2000 Corvette, 97, 98, 99 model, you're going to find one quick little paragraph on how to set this up, and the instructions are terrible. So I'm going to show you the proper way to set this tool up. So there's a convex piece on the back of this tool, and you can see it moving in and out right there. This needs to stay in constant contact with the cylinder wall throughout the entire setup process for best and accurate results. So what you do is you take it and you just set it just into the top of the cylinder bore here. You can see that convex piece right there. And you see it come out and make contact with the cylinder wall. Then you take your measuring rod, you bring it out and just lay it on top of the deck. So I have my convex piece of my tool just down slightly into the top of the cylinder bore. Measuring surface is laying on top of the deck. What you want to do is you want to pull this measuring rod back until that machine groove contacts the ridge of the cylinder wall. You can feel it. You can feel it kind of click when it makes contact. So right now what I'm going to do is that silver knob on the front of the tool, I'm going to tighten it up. And you want to get it tight, right, so your tool doesn't slip on you. It's kind of hard to do with the phone in a way, but okay. So my next step, I'm going to compress the center of the tool. I'm going to compress the center of the tool. Pull the whole thing down to the cylinder bore. And now I'm keeping pressure on the front of the tool here to keep that convex piece right there in contact with the cylinder wall. So where I want to measure in the cylinder, just for my diameter of my cylinder bore, see if I'm in spec or not in spec, I want to bring these sleds, that's why they call it a sled gauge. You got sleds on the back of it. You can see them here and here. I want to bring it down to where it is level with my deck. So my sleds are now level with the cylinder deck. Next step, you're going to tighten that knob right there on the side. That's going to tighten and prevent the movement of the center of the tool. Once I'm there and that's tight, my final step is to tighten the handle. Now this tool, like we talked about earlier, these tools are old. I don't know exactly when this particular one was manufactured, but I'm going to guess in the 1960s or 1970s. I should feel a slight drag on the tool as I go up and down the bore. You don't want it to bind up in the bore, so if it binds up in the bore, then we got a problem. So I'm gonna go ahead and just make sure that that is tight, that is tight, and that my handle is tight. So what I want to do, I want to take a micrometer. That's what we're going to do next. I want to measure from here to here and compare it to the specification for my cylinder bore. So I'm just going to lay this right here where you can get a good look at it. Hopefully it shows up on the camera. And we're going to take a micrometer and we're going to take a quick measurement. Okay. So remember, both ends of this are convex, so you want to get up on the highest pieces of the convex. Typically, I'd probably have this handle, this sled gauge, clamped into a vise for you where it would stay still, but just for the purposes of the video, I want to be able to, I want you to be able to see what's going on here. So I'm going to see where, make sure this feels okay. I'm going to lock down my micrometer, 3.513 inches. Now if I'm looking at my specifications for my cylinder bore, 3.4649 is maximum cylinder bore diameter. The cylinder bore is actually oversized at 3.513. That's the purpose of this tool, is to help you determine the size of your cylinder bore. Of course, I can use it and measure around my cylinder bore this way and measure at the top of the bore, middle of the bore, and the bottom of the bore to get a full picture of how out around I am and if it's tapered at all. Of course, you know, if you're out in the shop and you're working and you think you do have, and the whole purpose of this tool is, okay, if I think I have a defective engine block, well, now I can prove that the engine block's defective. We just proved by the proper setup and procedure of this sled gauge here that this cylinder bore is oversized, and this block, you know, it's an aluminum block with cast-in cylinder liners. Don't really know if I can get oversized pistons for a little Ecotec engine, or if boring this block out, if there's even enough material here to be able to do that. I think I'd probably be replacing my engine or seeing if I could source another block and rebuild this engine maybe for my customer or whoever it belonged to. But it's a real easy tool to set up. It's just that we don't have enough instructions on how to set it up available to us. And of course, because of the age of this tool, a lot of that stuff doesn't exist anymore. So just a real quick, easy setup for a sled gauge to measure your cylinder bore. Now, are there other options for measuring cylinder bores? Yeah, absolutely. There's something called a dial bore gauge. So, you know, check back in the channel and look for a video for a dial bore gauge and how to use it, because it's very accurate tool and also very easy to use. So we'll produce a whole nother video for that. But I do want to point out one thing. When you're measuring a cylinder bore, you do have an option to use one of these, a T-gauge. Sometimes you might hear it referred to as a snap gauge, because when you loosen the handle on the end of it, it snaps open. It's got a little spring-loaded measuring surface in here. So the idea is you put this in the cylinder bore and you snap it open. I almost lost my sled gauge here. You put it in the cylinder bore and you snap it open. And you can get a measurement. Well, that's great. I understand the concept and I have used these. I even own a set. The problem is, to get an accurate measurement using a snap gauge, it has to be completely level on the cylinder bore. It's very difficult to do because there's nothing made onto the snap gauge, or nothing I could put on this snap gauge to actually make sure I'm 100% level on the cylinder bore to get an accurate reading. So a sled gauge, or a dial bore gauge, which we'll put in the next video, would be the way to go. Hey, and if y'all like this video, just give me a thumbs up, like the video, maybe subscribe to the channel, and look for more to come. Thanks.